Given a string and a dictionary of words, decide whether the string can be fully segmented into dictionary words. Apple, pen, apple splits into apple, pen, apple. All three are in the dictionary, so the answer is true. Now cats and dog. Cats and are both in the dictionary, but the leftover og is not. Would a different cut work? And how many cuts must we try? Brute force. Define wob start. Can the suffix starting at index start be segmented? Start recursing from wob 0. At index 02 dictionary words match the prefix cat and cats. Each match opens a branch. From index 3 we match sand. From index 4 we match and. Both branches land on index 7. At index 7, the leftover og matches nothing, so both branches return false. As the string grows, the number of branches explodes exponentially. Look at these two nodes. Whether we take cat plus sand or cats plus and, we end up asking the same question. Can wob7 be split? The value of wob start depends only on the index, not on the path taken to reach it. Cache the computed answers and the exponential search collapses into one table. First step of DP. Define the state. Unlike optimization problems, here each DP value is simply true or false. DEPI means, can the first I characters of S, that is, 0, 1, be fully segmented into dictionary words? Note that I is a length, not a position. For example, DP4 is true, because the first 4 characters spell cats, which is in the dictionary. But DP2 is false. The prefix CA cannot be cut into dictionary words in any way. The final answer is DPN. To decide whether the first I characters split, ask one question: where does the last word begin? We do not know, so we enumerate. Let the split point J run from 0 to I1, cutting the prefix into 2 parts. A cut works only if both hold. DPJ is already true for the left part, and the right part, SJI, is itself a dictionary word. If any such J exists, DPI is true, so the recurrence is an OR overall J rather than a max or minute. Time to fill the table. The top row holds the characters of S. Column I covers the first I characters, so the table has one extra column. Base case, DP0 equals true. The empty prefix needs no words at all, so it counts as splittable. DPON and DP2, the only candidate cut starts from DP0, but neither C nor CA is in the dictionary, so both are false. DUP3, take J equals 0. DUP0 is true, and 03 is exactly cat, which is in the dictionary, so DUP3 is true. DUP4 is similar. With J equals 0, 04 is cats, also in the dictionary, so DUP4 is true. These 2 columns are the 2 branches of the decision tree. DP5 and DP6, starting from DP3 or DP4, the leftovers are sa, ah, san, an. None of them is a word, so both are false. DUP7 has 2 valid cuts, DP3 plus sand or DP4 plus and. Either one suffices, and this cell is exactly the wob7 that the recursion computed twice. The last 2 cells, the dictionary does contain dog, but it would have to follow DP6, which is false. Every cut fails, so DP9 is false. Cats and dog cannot be segmented. Summary. State DPI equals can the first I characters be segmented. The recurrence enumerates the start J of the last word, and ORs over all J where DPJ holds and SJI is a dictionary word. Base case DP0 equals true. Time on 2 and space on.